So welcome everybody to my talk about unraveling the threads, event sourcing, CQRS, and event-driven architecture. And I hope you enjoyed the lunch. So a little bit about me. Who am I? I'm from Munich, Germany. Studied computer science millions years ago. I'm working for more than 25 years in the industry as a developer, architect, trainer. I also manage people and whatnot. And the last 2.5 years, I was working at Mayborn Wolf in Munich, an IT consultancy, as a learning designer. And what does a learning designer do? It's basically developing and conducting workshops. So I generally also do mostly workshops at conferences, not so many talks. So forgive me if I'm a little bit nervous. The topics. We'll start with event sourcing 101, then move to CQRS for dummies and event-driven architecture basics. And then it will get interesting. I'll show you how to shoot yourself in the foot with all this stuff. And then I try to show how to avoid shooting yourself in the foot. And finally wrap it up a bit. So this is a basic talk for people who have done all this stuff. It might be a bit too basic, then you will just feel free to leave. The core idea is to first show those three concepts in isolation, because those concepts are just orthogonal. They can be used together. That's sort of mostly in the second half. But yeah, they don't have to be used together. And sort of forcing using them together is, yeah, a big part of the problem that some companies discover. Some words about the examples and the diagrams. They're very oversimplified so that you won't die in details. For example, I'm mostly leaving out system architecture like monolithic or microservices. I'm also normally not drawing the service boundaries, so might be monolithic with modules, might be microservices or something in between, because yeah, I think that's not so important here, because yeah, I'm trying to focus on the core concepts. So let's start with event sourcing. Quick check, who has done event sourcing in production? Hands up. A couple of people. Who has done CQRS in production? Yeah, sort of the same amount. And event-driven architecture, that should be more. Don't be shy. Yeah. So yesterday we had a talk, I think even here, basically about monitoring, tracing an EDA system, and we've seen it's, yeah, not super simple. So event sourcing, what is it? Instead of storing the state of an entity, I'm just calling it entity for simplicity. So it could be a process, an aggregate, doesn't matter, a thing. So instead of storing the current state, event sourcing records the sequence of changes known as events that lead to the current or led to the current state. And the sequence of events for one entity is typically called an event stream. And to obtain, I'm switching to German in between, funny. To obtain the current state of an entity, you just apply the events from an event stream in sequence as they happened. And this is typically called projecting them. Projection doesn't matter so much. Events are immutable, meaning once they're created, they cannot be changed, should be known. And, sorry. Events are stored in an event store, which can be a specialized DB product, like Event Store DB, the product from Greg Young, who also coined CQRS by coincidence, the term. Or it could be any other relational DB or other types of DBs, so document stores or even the file system. apart from event store DB, which is, as far as I know, the only really specialized product, there exist a couple of, call it libraries or frameworks, Axon, for example, MartinDB. That's some I know, I haven't used, but I know them. But it's not too complicated to implement an event store by yourself. I've done it even in production without issues as far as I can remember. Still, generally, I would not recommend to do that just for learning. That's very interesting to see what properties you need to implement, what functionality for event sourcing, but in production, maybe it's better to use something that's specialized for that and has solved all the problem. So let's have a look at an example, a bank account. This is very naive and oversimplified probably. I've never worked in banking. If anybody does, forgive me. It should deliver the message. As we see here, we have an event stream just containing 4 events. And so that the people in the back can also read it, I'm showing basically the events here one by one. So everything starts with an account opened event, which has an account number, an account holder ID, a holder name, and a currency, and some metadata. Each event has an ID. Each event has a stream ID, which is used to basically bind the events together into one event stream. So in this example, it's sort of a prefix. It's an account and then the number we see here. Then it has a stream version, the event type, account opened, and an occurred at date. So some timestamp that tells us when the event has happened. I'm using some ISO format with milliseconds resolution here. That might not be necessary. Seconds might be enough. In other cases, other domains, you might need nanoseconds. But then it depends on the clocks of your computer or your servers. So details, again, not so relevant here. It should just be a parsable format. That's a good idea. Then the next event that happens in our example is money deposited, 250 euros. Stream version is updated. So now the person also has some money on his account. And for sure, he or she directly withdraws something, 20 euros, stream version updated. And finally, we have an account maintenance fee charged event. I have no idea if this is in some way realistic, but my bank does that. Probably your bank also does that. So I'm pretending that's €1.95, and the stream version has changed again to 4 because it's the 4th event. Then let's look at how the events one by one basically are projected to the current state of the account. I hope that's still readable. It's not too complicated. First, we just have an account with a balance of 0, with a number, holder ID, holder name, and a currency, and the stream version again. Then when some money is added, we have a balance of 250 in that case. Then 20 are withdrawn, and we have 230. And finally, when the fee is charged, if I calculated right, we have 228 euros and 5 cents on this account, and the stream version is 4. So next, we're gonna have a look at the life cycle, typical life cycle of event sourcing. It always starts with a command coming in, which is typically the imperative form of what the events are. So open account would be a command for the first thing that can happen in that case. The event stream is read from the storage. The current state is projected from all those events that we already have, as we have just seen it. Then a decision is made based on state, command, and business rules, constraints, which leads either to the happy case, which results in 0 to n new events. Typically, I would say it's exactly 1, but doesn't have to be. Anybody knows why it can also be 0 events? Hands up. Nope. That's idempotency. So imagine we receive a command that would not change the state of the system. Why should we produce an event that says basically nothing has happened? So in that case, it's 0, or more. And then we have the error case. This might produce an error event or just throw an error. It's partially an implementation detail, but I would say it's mostly business logic. If such an error event might be interesting for the business, then it's a very good idea that the error cases produce error events. And then you can map it to an error that you throw to the customer, basically, or the user of the system. Generally, I would recommend to have error events, even if there is no strong business case for that, because it might be useful information. You might not even know it today, but tomorrow you might need it, and then you're happy if you have it. For sure, there might also be counter indications. So I don't know all the domains in the world, but let's say for one domain, it's very typical to produce a lot of error cases. Then you might produce a lot of error events and create a very long event stream that's mostly error events, and that might be a reason not to do it. So it's always a case-by-case decision. And finally, concurrency can be addressed with optimistic. Sorry, I skipped one point. Number 7, all new events are stored unless the event stream has changed in between. So we have a conflict. And this concurrency can be addressed with optimistic or pessimistic locking. And the handling of conflicts varies. Meaning, in some cases, you just can retry 2, 3, 4, and then 5 or 6. Might be a valid case, because when you basically reproject with the changed event stream, then you can still make your business decision, and it has some outcome. In other domains, it might be more feasible to return the error or the conflict to the user of the system, because he or she might make a different decision when the state has changed. Yep. Some benefits of event sourcing. When you sort of ask the internet or ChatGPT about that, when you ask 10 times, you get 12 different answers. So this is not a complete list. This is more or less what I think is important and what I like about event sourcing. So it's flexibility. You can easily add new features by introducing new event types without altering existing data. More flexibility. You can easily change how the state is projected. So basically, the internal structure of your aggregate entity write model, for some reason you want to change that, just change the projection, and it still works as expected. More flexibility even. You can add new models at any time, and that's what typically happens quite a lot with read models, because business says, hey, now we need a new report, or we want to show something different to the customer. So just implement that new read models and you're done. Auditability, that's what I think is always mentioned. Every change is recorded as an event, providing a complete audit trail. Auditing is, as you might know, important in some domains. I think banking might be such a case, or stock stuff, or anything that's critical infrastructure, I don't know, nuclear reactor, and there might be thousands of other domains that need auditability even by law. In other domains that don't have that need for auditability, it's still very useful, yeah, because you can always reason about why has a state change happened. You can also reason about errors. If you look at the point of the basically previous event, what was the state, and then you can find out, hey, the next event didn't change the state as it should. Maybe because of a wrong projection, maybe because of a missing projection when a new event was added, whatever it is. So yeah, easy to reason about that. Then we have historical analysis. So as we store all changes, you can analyze past states and decisions, which is valuable for BI and compliance. You can, for example, in the example of a bank account, you can say, hey, what was the account balance at some date? Or you can say, what was the volume of withdrawals in a certain amount of time? So generally, all those temporal features, yeah, that have to do with the time is a property that event sourcing brings for free, and you can ask it questions easily that you cannot ask a stateful model. So might be a big benefit. Then this is a bit personal, maybe no DB migrations, no ORMs. I guess some of you have run DB migrations that sort of failed. Only 0.01% of the records were affected and blah, blah, blah. A lot of fun. And then maybe you can roll it back, maybe you can't. And ORMs, yes, I'm not a big fan of them. I used to be when I was a bit younger. But they tend to be complicated. So that's all stuff that you don't need and don't have to do with event sourcing. And then, yeah, the last one is a little bit of a joke. Dennis probably knows the question. No, it's not complicated, and it's also often not too slow. So typically when I do an event sourcing workshop or just talk to people about event sourcing, that's the first questions that come up. But isn't it complicated? Yeah, I think, no, you've seen the pattern. I think you know a couple of enterprise patterns that are 1 trillion times more complicated. And it's also not often not slow. I mean, what is slow? How fast do you have to answer? It depends a lot on the length of your event streams. So if you just have to read and project, let's say 1,000 events, that's typically fast in the sense of whatever, 50 microseconds, I don't know. That depends on a lot of factors. If your event stream is 5 million events, then eventually it might be slow. There are solutions, you might have heard about snapshotting and blah, blah, blah. Don't want to dive into details here. But from the beginning, it's just an assumption that people have. And as I said, it's often not true. Okay. That was it about the S for a moment. Let's move on to CQRS, and I'll sip a bit of water. I think this is the biggest wall of text that I have, so forgive me. We will continue more with diagrams. So CQRS is sort of an extension to CQS. CQRS is command query responsibility segregation. CQS is command query separation. And CQS basically just says commands should not return data and queries should not change the state. You might have heard of the question should not change the answer for the second part. And what CQRS adds is that different models in your code, in your architecture, should be responsible for handling commands, write models, versus answering queries, read models. which removes a lot of coupling, complexity, and cognitive load, and elevates changeability, because you just have two smaller models instead of one big to do the stuff. So maybe to show a bit the difference between CQS and CQRS, if you look at a class in some OOP language, if you have getters and setters or mutators, that's basically CQS. If the write methods don't return anything, just void, and the read methods don't change the state, then this is CQS. But it's not CQRS, because there you would have, let's say, two classes in that OP example. And that's it. It doesn't say there should or must be different databases or a message broker, but there can be different databases for performance optimization or horizontal scaling. And we'll touch that later a bit. That's what why people often build more complicated solutions, because they think premature optimization, they need performance optimization and horizontal scaling before they really know about it. Or it can be used, CQRS can be used to aggregate data from different sources, where we start to touch EDA, which we'll look at later, because you typically have a message broker to be able to aggregate this data from different sources. You don't have to, you could also do all sorts of queries to aggregate the data, but that's how it's typically done. And finally, event-sourced applications typically use CQRS, albeit often for the wrong reasons. Again, premature optimization, because isn't it slow? We know that there are valid reasons in event-sourced applications to use CQRS. The one example that comes to my mind that's sort of a no-brainer, when you need to basically collect the data from different streams, like in a collection. Then you would have to read from a lot of different streams, and this is very likely to be not performant. And there might be different examples, but that's my go-to example for event sourcing. Okay. Let's look at some examples how you can implement CQRS, because literally unlimited possibilities, and not just to implement it, also how to make it incredibly complicated. So let's start simple. We just have some user interface that interacts with some write model. Again, I've mentioned simplification. This might be one service, this might be a service, not important. So here's the write model that stores data to the database. And here we have two read models that read data from this database and deliver it to the user interface. And the numbers are just random. There might only be one read model for sure, or 17, and also some write models, not important. But very simple solution, and that's CQRS. A bit more complicated, sophisticated, aggregating data in the read model. So in this case, we have three write models with their own DB, and the read model simply queries all those databases or a couple of them and sort of aggregates the data here and delivers it to the user interface. Still no message bus. Then we could say, hey, we update write and read database or models within one transaction. So same as before, three write models with their DBs, but additionally they also update the database that is there for the read model. So basically the heavy loading is on the right side, and the read query just needs to read something that's already sort of prepared, aggregated for this query, which might be very handy for yeah, performance optimization, and in many or most, I don't know, systems, we have more load on the read side than on the write side, and also it's more acceptable that the writes take a bit longer. So this is sort of a logical solution. Hey, now we have a message broker. I have to point here. Finally. So what we do here is updating the read DB asynchronously. That part is the same, but additionally we publish events to the message broker, and then there is some event consumer which aggregates the data or whatever it needs and puts it into a specialized database or table for the read model. So we have the same advantage as before, possibly, that the read queries are very simple and very fast, and we can use whatever MongoDB or Redis, something that's super fast. And the heavy lifting is in the event consumer. The reading part is super simple. And this is also what typically when you search for CQRS, you see graphs that are a bit different or graphics that are different than mine, but that's the idea behind it. It's kind of sold as if CQRS means a lot of databases, a lot of services, and definitely a message broker. So the combination with EDA, which is not per se true. And finally, for CQRS, I have two examples for event sourcing combined with CQRS. That's from an article I once wrote for Event Store DB, the product for their blog. The one on the left is the simple one. So we see there is just one event store in our order service, which adds to an event stream, reads the event stream, projects to the right model to make the decisions, yeah, and then adds events here again. And we see the read model is doing exactly the same. It's just reading this event stream and projecting it to the whatever read view, read model. I call this live projection. This is not an official trademark name. Whatever other people name it. But yeah, the core is the query model is not prepared. It is built on each request, which might mean that if you need super high performance, that's too slow. But again, often it's not too slow. If you have a small event stream, it's fast enough for many, many applications. And on the right side, we see the more complicated solution, which also has a message broker. So it's EDA already again, where the order service, the write model is basically the same, except that it also publishes the events when they are added, publishes them to a message broker. And then there is another service, the order view service, with an event consumer that's updating the read model, views, whatever, by projecting new events as we have seen it, stores them to a read model store, which is then simply queried, and those documents are delivered to the user of the system, to the user interface. So this is nice, but when you compare that two things, we have an additional service here. We have a message broker, okay, that's infrastructure, but we additionally have a new service with an event consumer and another store. This and the projections are basically the same here. So it's more moving parts, more things that need to be maintained, more things that can be done. And that's what is kind of sold to you again when you start with that stuff and you search on the internet. That's sold as the solution. And if we have seen before, there are much simpler ways, and we also see it on the left. So Use your brain. Don't do the most complicated stuff without a reason. When there comes the time that stuff really gets too slow or needs to be scaled, then you can still switch to the more complicated solution. Okay, so much about CQRS. Let's look at EDA. Yeah, very naive, extremely naive e-commerce example without EDA first. So that's pure fantasy. Amazon is not working like that. But as I said, I want to keep stuff simple. So here we would have an ordering thing. I don't care, you call it subdomain or service or multiple services. That's just a detail. But ordering is sort of orchestrating everything. It's probably querying the catalog to get all the items we have on stock to show it to the customer. There is an UI connected to it. And then when an order happens, it might tell the payment subsystem, hey, please get me the money from the customer. And then when payment responds, hey, I got the money, it might tell the shipping thing to ship the thing. Ha, that was a good one. Accidental jokes are the best. And as shipping typically takes a couple of days or at least hours, then maybe at some point shipping tells ordering, hey, the status has changed, it's on the way, you know all that from your package tracking. And finally, hey, it has been delivered. And then finally, ordering might tell the catalog, hey, there is one less item on stock. In between, it might tell it, hey, one item is reserved. I don't know. I've never worked in e-commerce as far as I remember. Could also be that shipping tells the catalog the thing, well, yeah, you have one less of that now. It doesn't matter. So the core is here. We have synchronous requests. And each subsystem must be kind of responsive, so that's temporal coupling. When an order is placed and payment is down or super slow, yeah, shit might happen. You might have to roll back stuff or whatever. The strategy is here. And the same with the other. If ordering tries to query the catalog and the catalog is not there, that's a bit problematic because we can't show the customer what we have in stock. Okay, now let's look at that same naive example with EDA. So we have the famous message broker here, the same services or subsystems that we had before. Here, each of the services or subsystems publish and consume relevant domain events. Relevant is relevant. We'll get relevant later. So anything that's important for might be important for the other subsystems. And then they consume events like crazy here, there, blah, blah, blah. So I don't know, ordering might consume catalog events. Then ordering might publish an order placed event, which payment might pick up and then get the money and then publish a payment fulfilled event. And then shipping might pick that up. And when shipping is done, and so on and so on. You know the story. What we see here, it's kind of uncoupled and independent, but it's not. We see that events are consumed from here to there and there to here. So not so much independence. On the other hand, a system cannot be independent. Any part sort of belongs to a system. But the core, we have asynchronous requests, event publishing and consumption. Subsystems can be down or slow for a while without bad things happening, because if something is restarted, for example, it will just consume the events that have happened a while ago from the message broker and do its work. So no temporal coupling or no strict temporal coupling. But yeah, as I've mentioned before, the dependencies between the subsystems for sure still exist. Otherwise, it wouldn't be a system. And additionally here, the message broker now is our critical infrastructure with very high availability needed. Otherwise, events might get lost. And the system is in some weird state because some process is stuck in the middle and will never pick up. For sure, there are a lot of compensation strategies. For example, the outbox pattern. So when anything happens here, an order, and that's stored to the database, then the message, the event, is also stored in some database, and then some sort of cron-like process basically publishes those events, meaning that if the message broker is down for 5 minutes, we still have those messages in the outbox, and they will eventually get published. But still, what happens if the message broker is down for 3 hours, for a day? 1 million things might have happened in our business domain, and then suddenly this guy comes online again, and all the outboxes are flushed. So we have an avalanche effect probably, which causes problems in all sorts of services or whatnot. So as I said, we can sort of work around the high availability need, but only to a point. Eventually, it should be quite high availability, have high availability. Okay. Now we've had a look at the parts in isolation. We've already seen where they can be connected. And now let's have a look at how you can shoot yourself in the foot. Who has shot himself or herself in the foot already? Dennis, that was sure. So yeah, I guess most of us, depending how long we are in the business. And we might have shot away the whole foot or just a toe. So jokes aside, same as we have basically seen before, looks like a quite sane system at the moment. Only ordering is event sourced, has its own event store DB, and the other 3 services, subdomains here, also like ordering, publish, and consume relevant domain events. Kafka is the message broker here, or RabbitMQ. All fine. But then the CTO probably has heard from a consultant from a company that starts with C, who does Kafka consulting, that Kafka is also an excellent event store. So he tells whatever the team that does the ordering stuff, hey, why do we have an extra event store here? We have Kafka, that's an excellent event store. And they move in this direction to use Kafka as an event store. I'm already grinning. I've written my most successful blog article on Medium had the title Why Kafka is Not Suitable as an Event Store. That has a lot of details. At the end, I will also show my Medium handle if you're interested. So yeah, it seems a lot of people do that or think about that. And it also shows that Kafka and something a bit controversial sells very good on the internet. So I don't think it was a clickbait title, but yeah, it's funny. And I also had a lot of discussions on Twitter, now called something different, when I published this article where some people tried to explain me what capabilities Kafka has and how you can do that and use it as an event store. At some point it falls short. It's not specialized for that. There are specialized solutions. I think we know we should use the right tool for the job. That's the bread and butter of software development, or one of the pieces of bread and butter. Okay, let's shoot ourselves more in the foot by making everything event sourced. So as there is a Kafka and it costs a shitload of money to maintain it and blah, 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 the bad CTO tells all the teams, hey, move to event sourcing. And they do a rewrite of all the beautifully working systems. Maybe not, maybe yes. Really? Okay. Turns out when I practiced my talk, it took 30 minutes. So I really talked much, much longer. I'm really sorry about that. So we're out of time. I will try to rush through the rest in 3 minutes, but that's funny. So we can also publish and consume all the event sourcing events. What could possibly go wrong? Then we can add many stateful read models where each should live in its own microservice. So we have a lot of more services, a lot more databases. Then we can also project all the foreign events into our own shadow copy of the data. So now here we have a shadow copy of catalog and payment and shipping, and we have a great coupling to the events that other teams maintain. So whenever they do some changes, we need to catch up and implement against that. And we do that in each subsystem. The more microservices, the merrier. How to avoid shooting yourself in the foot, be pragmatic. So here, this might be a very stable system and synchronous communication is fine. This might also be off the shelf and we plug in an adapter to make it EDA and also don't have a million read models, full-blown read models that are stateful, but some are stateless with the live projections. And wrap up, yeah, use event sourcing where it makes sense. You should also have developers that have some experience with it. Use CQRS, but in the simplest way that works for you, unless you have a good reason to build more complex solutions. Use EDA, but consider to allow pragmatic exceptions, as on the previous slide. Use the proper technology, not Kafka for event sourcing, no. Don't have 250 microservices. Don't enforce ES and CQRS as EDA as the top-level architecture. That's basically the baseline. And that was it. Thank you for attending my talk and enjoy the rest of the conference. I have to cross out questions now because I talked a bit more than when I practiced. And yeah, here you find my social stuff, including Medium. It's mostly Tony Bologna. So if you're interested, you can read that stuff. Thank you.